Oh, hey, welcome back from your break. Maybe you had a snack, played some Fortnite, hugged your brother, took a shower, went outside. Hopefully you did something that got you out of your seat. So actually, we're going to stop at number 11. So we're actually way more than halfway through, so that should make you feel good. So let's now move on with what's happening in communities. Remember, communities are only biotic factors looking at different species and distinguish between food chains and food webs. Now, people, I know that you've been learning about this since elementary school, but last year this showed up on the FRQs. Our kids knocked it out of the park, so let's make sure that we understand. So a food chain then is when you're looking at movement of energy from one trophic level to the next. Maybe you have, I have like a fancy pen, but it's not really working. Oh, I know what to do. Hang on, I want to play with this. I want to draw you a food chain. So maybe you have grass, grasshopper, bird, snake. Okay, ask yourself right now, which one is my producer? Which one is my primary consumer? Which one is my secondary consumer? Which one is my tertiary consumer? Is there a herbivore on there? Are there any carnivores on there? What process is that grass doing? These are all the kind of questions that you're going to be asked. But the key idea here is those arrows, those things are supposed to be arrows, by the way, those point in the direction that energy flow. That's really, really important. Arrows point in direction of energy flow. Okay, so it's basically pointing to the organism that's doing the eating. Okay, and then that food web is when we kind of attach them all together and we have this interconnected network of food chains. So that was number 7. Be able to interpret one. You're definitely going to see a picture of one. Maybe we'll practice a multiple choice with them together. All right, so here's a pretty complicated food web. Again, if you'd like to quiz yourself, oh, shoot. Let's see here. Let's see. Hang on. Figure out which ones are my producers, where are my primary consumers, where are my secondary consumers. It's hard to write on a screen. Tertiary consumers, and so on and so forth. Okay? Identify them, talk through them, try it. All right. Let's talk about energy in general now. So first we have to define biomass. So when you're talking about biomass, you're basically weighing each trophic level, each feeding level to see how much it weighs, which is kind of a wacky thing to do. As you move up, biomass decreases. As you move up, energy availability decreases. As you move up, number of organisms decrease. So that means that that bottom layer of that pyramid, those producers have the most biomass, the most energy, and the most in number. Okay, it's a pretty important thing. As we talk about energy loss, this is a really important concept, guys. You should be able to do the math, by the way. You're losing 90% every time you go from level to level. You're only passing on 10%. This is that 10% rule that you learned back in biology. So as I go from that grass to grasshopper level, only 10% gets passed on. If I had 100 kilocalories, only 10 of them would be passed on. Okay, so that's what number 8 is talking about. Now, there are 4 reasons this occurs. Please listen closely. Number 1, the organisms don't eat the whole other organism that they're eating. If an animal is eating an animal, they're probably going to leave behind fur and bones. If an animal is eating a plant, it probably can't digest bark. It might leave thorns. It might leave roots. So number 1, organisms don't consume it all. Number 2, of what they do consume, they can't use it all. Everybody poops. It's like a book and everything. Everybody poops. So you take in this matter and can't efficiently use it all, and all organisms have some sort of waste product. So of what they do consume, they can't use it all. Number 3, some of it's just required to digest and maintain their lives through metabolism. So some is burned off in digestion and metabolism. And number 4, if you've taken physics, if you've taken chemistry, you might have talked about the second law of thermodynamics, which is disorder is always increasing. And heat is given off when you transfer energy. If you've ever come to talk to me, when I'm sitting at my little desk, my computer is hot. Energy is being transferred. Heat's being given off. An engine in a car gets hot. So anytime energy is being transferred, heat is created. So number 4 is heat. That should help you with number 8. I also want you to make a note that you should be able to do the math. If you're going from level to level, you should be able to go from 10,000 to 1,000 to 100 to 10 if you're looking at some sort of trophic level pyramid with energy being explained there. So then number 9 leads you to then, why are there more insects than tigers? Well, think about it. Where is there more energy available? Because of loss of energy as you move up the food chain. That's our answer. It's hard to be on top. It's much more efficient to eat at the bottom where there's more organisms and more energy available. And then translate that to humans. If you've ever heard the argument that we wouldn't have any famine here on Earth if everybody was a vegetarian. Now, don't get me wrong. I like my steak. I like my chicken. But if everybody ate at that lower level, let's say the amount of grain or corn that you could feed people with, that you would feed to one cow, is staggering. So maybe that cow feeds 20 people when you slaughter it, but the grain used to feed that cow feeds 200. That's our 10% rule in action. So why don't most of the world's people eat meat? Because most can't afford to. This is number 10. They eat a lot of wheat and rice and corn. It's cheaper to eat lower on the food pyramid and more energy efficient. So then finally, let's revisit primary productivity. Ooh, that's our food chain. That shows the 10,000, 1,110 if you're a visual person. So we've alluded to this last unit. Let's talk about gross primary productivity. So we're talking about the, do I have it defined for you? Yeah. We're talking about the rate at which an ecosystem's producers, we're only looking at producers right now, convert that sun energy to chemical energy and biomass. So what are they converting here? What are they making? And there is a measurement there, a measurement that you will not have to memorize. You will have to work with some math problems, but those units will be given to you. Now, after they use what they need to respire and live and grow and metabolize, that's our net primary productivity. Okay, and it's a term that we use very, very often to describe how useful and how productive an ecosystem is. If you remember from the test yesterday, open ocean has really low net primary productivity. The rainforest has really high net primary productivity. And so we're going to keep kind of trying to refer to it to describe life zones on Earth. So if you look at the last slide for today, this reinforces what we talked about. Look down here at open ocean. Look at how low net primary productivity is. Ooh, swamps and marshes. I was wrong. Well, they're about the same as tropical rainforest. Desert, scrub, tundra, those all have really low primary productivities. The coral reef system should be right above where estuaries is, but it combines it with the other continental shelf aquatic ecosystems, but estuaries are really high. If you remember, estuaries are where freshwater and saltwater mix. Often there's high turbidity, nutrients getting kicked up, and therefore high net primary productivity. Okay, so then open ocean is valuable even though it has low NPP because it's so big. There's so much biomass. It does actually support a lot of our food chains. So that's the first half of the lecture. Tomorrow I'll be starting with slide 15. We'll be starting with number 11, and actually we're going to kind of jigsaw the nutrient cycles. I'll talk about the water cycle, but then you're going to become an expert in one of your cycles, and we'll finish this packet. Thanks for listening, and I hope this was helpful, I think is what I'm supposed to say. Have a good day.